Okay, hi all. So this is the continuation of the first recording. So we have dealt with the the operators and we have gone through the expressions. Now we are going to go through the equations, the formulas, and the functions. Okay. So I'm going to list the examples of the equations. Then I'm going to tell what is an equation. Okay, so for the expressions, we did not have the equal sign, right? So for the equations, we're going to have an equal sign. So let's say we are adding two numbers, 3. Okay, let me just erase this part. Just erase and use a different color. Okay, I'll just use this one. Let's say we add 3 plus 5. Okay, so when we're adding 3 plus 5, we're going to get 8, right? So now for the equation, there is an equal sign involved. Okay, so this is what this part is an expression. So we're expressing here, then now here we are equating this expression to something. Okay, the value of this expression is this one on the right hand side. So we call this as the left hand side and this side as the right hand side. Okay, so we have a left hand side and the right hand side. So we're expressing this left hand side to something that is on the right hand side. Okay, so let's go to the second example. So let's say x minus 1 is equal to 0. Okay, so we are expressing here on the left hand side. Then we say uh, this expression is equal to 0. So this x plus 1 is equal to 0. It's not always the case where like you are expressing something on the left hand side to something to the right hand side. Like we say, maybe we can say 0 is equal to x minus 1. This is the same thing. Okay, so expressing this, we say it is equal to 0. Okay, so we should bear in mind. Then we have the other example. Let's consider this one as let's say this is x minus 5, okay, divided by 2, which is equal to a half. Okay, so this expression on this side, so we have x minus 5 divided by 2, which is equal to a half. Okay, this is an equation. This is an equation. This is an equation because there is an equal sign. This equate, this part equate means equal to equation. You are now equating something to, you are equating an expression to something. This equate on the equation means you are equating something to something. Okay, now let's consider the other example. Let's say this is 4y plus 7 is equal to 15. Okay, 15. Okay, this is an equation. We have this variable here, we have this addition sign, we have this constant, we have the coefficient. This is the coefficient. So on the right hand side, this is the left hand side, this is the right hand side. Okay, so there is an equation, there is an equal sign involved, so this is an equation. So now we can consider the other example. Let's say we have x minus 2 is equal to 4. Now we have x minus the sign and the 2. So this is an expression. So there is an expression equated to something. So this expression, this one is equated to 4. So it makes this whole thing as an equation. So an equation is like a sentence in maths. Okay, should bear in mind it says two expressions are equal and it always has an equal sign. Okay, so this part is like a sentence in maths. So you are adding, subtracting, multiplying, dividing expressions. So in maths, like you are doing those things. So now this two expressions. So let's see here, like this left hand side is an expression. This right hand side is also an expression. Okay, so 15 is 15 is also the same as 15 is also the same as, wait, we use sorry about that. So 15 is also as like 15 plus 0. Okay, this is also an expression. Okay, you should bear in mind. So we have two expressions that are equated to each other. So this equal sign is equating these two expressions. So this part, they are always the equation always has an equal sign. So here we have this equal sign. Okay, we have this equal sign, also equal sign, equal sign, equal sign. Okay, so the equation always has an equal sign. Now let's go to formulas. So I'm going to list the examples of formulas. So one thing I can tell you about the formulas are always there, they can't be modified. They are always like, if you want to calculate something, if you want to evaluate something, you use formulas. So formulas are something that you cannot change. Okay, things that are already in maths. So there are researchers that came with formulas, are still using those formulas. So let's consider these formulas. I'm going to list the area of a rectangle is length times width. So we can also write it as L times W. Okay, so this is the formula of a, if you want to calculate the area of a rectangle, so you use this formula. So it applies to all the rectangles. Okay, so if you want to calculate the value of x in a quadratic equation, you use this. You are evaluating, you are finding the value of x in a quadratic equation. So you say x is equal to negative b plus or minus this square root of b squared minus 4ac. Okay, this is also divided by 2a. So if you want to find the value of x in a quadratic equation, you use this one. So for the simple interest, you say I is equal to t times r times t. So for the area of a circle, you say a is equal to pi times r squared. Then for the area, sorry, not the area, the circumference, if you are calculating or evaluating the circumference of a circle, you say C is equal to 2 pi r. So then if you want to find the formula, sorry, if you want to find the value of the volume, the volume of a cylinder, so you say V, yeah, evaluating the volume of a cylinder, V is equal to pi times r squared times h, which is the height. Okay, so these formulas, you will always find them in maths. Okay, they were like used by the researchers, so they will always be there in maths. So you'll never like find the other way to evaluate the value of x in a quadratic equation. You always like use this one. You will always use this formula to find the value of x in a quadratic equation. So those are the examples of the formulas. So a formula is a type of equation. So it's a type of equation that gives you a set of instructions or a rule that you must follow to find a specific thing. Okay, so we can see like they are like more like equations, but we don't call them as equations. We call them as the formula, since like we can't modify them. So these equations, like these specific equations, you can find something like for instance here you're like finding what you are finding the value of x in a quadratic equation. Okay, so these are formulas. Okay, now let's go to the functions. I'll first uh, give the examples, then define the function. Okay, so there are lots of functions in maths. I'll list just few functions. We have the scalar function, which is a line graph. So we can say f of x is equal to x. Let me just write the general formula. The general formula for f of x. So now for the line function, so it's mx plus c. So c is the constant, is any real number. Okay, then this one is a gradient. Okay, so here like you are generating, you are finding, so a line graph is something like this. So let's say this is the Cartesian plane. So this is our line. So f of x is this red line. Okay, so we can use the functions to evaluate or research something. Okay, so and this is the other function, which is the quadratic function. So it's ax squared plus bx plus c. Okay, so we can have something that looks like this. So this is, so it's very important to have this. Uh, so we have this. We can also have this. Okay, let me erase this part. So we can have something like this. Okay, we are going to um, we're going to go through the functions, but this is just the introduction. Okay, so let me just list the functions. So we have f of x. So it can be g of x, can be t of x, can be anything, like can be f of x, Okay, let me just use t of x. Okay, let me just say t of x because um, some people would be puzzled, why are we using t of x? So t of x, f of x, you can use t of x. So sine of x, okay? We can use here h of x, okay? So this can be f of x, okay? Sine x. This is h of x cos x. This can be anything like maybe y is equal to tan of x. So tan is also written as sine of x divided by cos of x. Okay, we are going to go through the functions. Shouldn't worry. Okay, so we can say this is um, the h of x. So which function we can um, let's say we have x x minus x squared, say x squared um, minus y squared. Okay. Um, okay. Let's say the function is. Okay, let me just erase this one because this is implicit. There are explicit functions. There are implicit functions. So this one is implicit. So let me just erase it. Let me just use a different one. Let's consider the logarithm function. Let's say f of x is equal to log x. Okay, so this one is is the explicit function. So the exponential function, let's say h of x, let's say it's e to the power x. This is the exponential function. Okay, so we're going to go through these functions, but not now. So in general, a function, so a function, functions are nothing more than a set of instructions. Okay, this is the general. There are like lots of definitions of function. So generally, like functions are nothing more than a set of instructions. Okay, so for the next one, we're going to deal with the other basics, but this is the introduction. Okay, so that's all for this recording. Thank you. If you find this informative, please like, comment, and subscribe if you have not. Thank you.